Yeah. Hi, everyone. So, as Brian just said, I'm going to talk about upgrading MoveIt, about using MoveIt, and more specifically about upgrading your MoveIt experience as a user there. Before I go into that, let me talk about myself for a moment. So, I'm a PhD student at Hamburg University, Group TUMS. You might remember them from 2 years ago at IROS and ROSCon. Distribution maintainer with the Linux distribution Luna Linux since 2007. So I've seen quite a lot of people trying to maintain software over the years. Since 2013, which is apparently not a long time compared to many of the other participants here, but anyway, I'm involved with ROS, contributed many patches already. Over time, I worked with quite a lot of robotic hardware platforms, including PR2, UR5, Shadowhands, and also some others. And then after using the MoveIt framework for more than 2 years, I became a maintainer there, and now I'm one of the maintainers of the MoveIt project. Let me stress here, please, that there are 10 official maintainers, 12 official maintainers, I think, at the moment. On the mailing list, I'm one of them, and I'm known to have some strong opinions, so not everything I say reflects on every maintainer here, but it's my personal opinion. Okay, so first things first. Who in here used MoveIt before, personally? Like, whoa, okay. That's more than half, I guess. That's a good thing. So you already know what this is about, right? It's one of the standard demos. You have Arvis running, your MoveIt plugin loaded. You can drag and drop around your end effector marker. And you get inverse kinematic solutions. You can click plan, and some magic planning pipeline will just do the job, generate a plan that avoids collisions, and and you can actually execute that on a robot, and the framework will also monitor the execution. So, if everything works so great, then why am I giving this talk? Over the last couple of years, I talked to many people about MoveIt, and basically when you ask them whether they use it, I found that there are 3 categories of people who reply to that. So the first one is like, yes, of course we use MoveIt. Everyone uses MoveIt. It works great. Why do you ask? Many of you are here. I'm happy to see that. Then there's also the bad side. It's the people who say, like, yeah, you know, we tried it. We didn't get it to work, so we don't use it. Now we roll our own stuff. And of course, that's bad for me to hear, because I like people to see using the framework successfully. But that's also bad for the community in the sense that many of these custom codes are not contributed back, right? And we want to see it contributed back. We want the community to improve. And then there are all these in-betweens. Like, yeah, you know, we use MoveIt. We use it for some things, and that works great. And then there are many things where, yeah, you know, we use just other stuff. Basically, my motivation for the talk is, on the one hand, to reinforce the belief of those who in the first group, maybe to convince some of the second group to try again. And for the third group, I want to encourage you to actually provide pull requests, to provide patches and modules, because, well, apparently you're working in a borderline case where MoveIt works to some degree, but, well, you know, it could be improved. Before I go into that, let me talk about stability for a moment. Like 3 years ago, there was this rather strict policy with MoveIt, within the MoveIt maintainer community that said, well, yeah, you know, don't change anything. If you change something, it's so likely you're going to break something because it's really complex code. Just don't change anything. Yeah, that's a way of putting things. Sadly, there were also many pull requests and many patches and many bugs, right? And they weren't considered, or they weren't given proper thought at that time. So let me contrast that attitude with a quote by Ulrich Draper, who was for a long time core maintainer of the GNU libc. He said, well, no program which depends on broken behavior deserves protection. If a programmer has found such a discrepancy and changes the application to use it instead of reporting it to the library maintainers, she gets what she deserves. That's an attitude. So just to skip this perspective in here, is more or less my personal perspective, I totally see that Toten does not totally fully apply with MoveIt. So it's not simple when your code decides controls for costly robots, right? If there are people involved, safety involved, then you can be happy that the end user actually managed to get the system running. And if you change something in the behavior of the code, then you might just freak out the developer who implemented his scenario, nothing works anymore, the robot goes crazy. You don't want that either. So on the one hand, stability is essential. On the other hand, so are correct implementations, right? So we want to see patches. We want to see upgrades if they improve things. Takes a lot of time to check that. So just in order to make the conscious decision about whether we change things or not, we added SO names for library versioning with MoveIt, which seems to be rather uncommon for ROS projects. And talking about branches, Indigo is by now considered stable, so we try very hard not to break ABI there. If we do, we can at least mark it, but we don't want to do that, seriously. Kinetic will stay API compatible, but we are likely to break ABI there again for adding features. And well, Luna is at the moment still released from Kinetic Devel, so the moment we start changing API to improve it, you will see that we branch off Luna. Okay. You might remember Dave Coleman's talk 2 years ago. He had one very depressing, in my opinion, very depressing slide in there that showed the commit history of one of the MoveIt repositories. And basically, there was a lot of activity in the graph, and then there was one small peak and one arrow pointing at it that said Willow Garage closed, and nothing afterwards. There was, well, yeah, he gave the talk back here at some point. So as you see from the whole commit history of the project, a lot happened, right? So it's not like we dropped that and nothing happens there anymore. What happened? We merged pull requests. We merged all the repositories finally into a central repository. That was a very good choice, made maintenance much easier. Since the merge, we already closed 379 pull requests. I actually wanted to make that 380, but didn't get around because I had to prepare the talk. We fixed many bugs, added many small features to the main project, and if you have not seen it, there's a new video montage 2017. Look at it, it's awesome. So, talking about upgrading, if you use MoveIt, try to use the current releases. You will see that since 2 years ago, there have been countless bug fixes and many things that just improve your everyday experience. So there's, for example, the collision matrix that you maintain within MoveIt, the allowed collision matrix. Now we actually have a visual collision matrix in the setup assistant, so you don't have to click your way through individual items anymore. We have synchronous scene updates. We have start state validation for execution, so that you don't execute trajectories just being somewhere totally else. Interactive trajectory display. You can just go through your trajectory forward and back in Arvist to see what it looks like, and some other things. Okay, let's have a look at more or less typical user experience with MoveIt. I guess more or less every one of you knows this robot arm, right? It's a UR5. It's very common among ROS users at the moment. So imagine you just set up the system, and you have it running on Kinetic. You just start up MoveIt, set up the configuration, and say, please make it such that the end effector is on the other side of this wall. And then you click Move, and something like that will happen. So, of course, this is slowed down a lot. You could go much faster. So technically, there's nothing wrong with it. You asked it to move the end effector to the other side of the wall, and that's what it did. Right? It's collision-free. It's well time parameterized. You can just do it. Nevertheless, a lot of people just think, you know, this is a bit weird. That didn't look too intuitive. Yes, you can improve on it. That's just the out-of-box experience, maybe. Well, it should be the out-of-box experience. If you see worse trajectories than that, you should seriously consider it a bug. And we had such a bug in the past. So where can you go from there? Just some random ideas here. If you tell the pipeline that a single-shot planning solver to go to move the end effector to the other side, you have not specified an inverse kinematic solution. So it's just going to choose the first one for which it finds a working plan, right? So if you wanted to have a short plan, maybe you should have a look at the IK solutions and choose the joint solution you want to have. If you don't want to get close to walls or objects, add padding, right? Collision objects don't have to have the size of the real object. You can add padding there. That's the simplest way. You can also add padding to individual robot parts. If you know you're not using your whole joint workspace, joint configuration space, and with the UR5, this is 4 pi in each joint, then don't use it. Specify not to use it, because the search space just gets much bigger, right? So if you can reduce that, things look much better. And of course, OMPL's default backend, that's flagship and planning, and there are lots of planners and lots of options. You can play with that for almost endlessly. Yeah, so you can improve a lot there too. But let's just take a step outside of the actual MoveIt core framework. You can, for example, find things like STOMP, which is stochastic trajectory optimization. Just sample some trajectories and some modifications. You can have a look at the details if you like, and generates a trajectory. And the trajectory looks like that, which seems much more intuitive, right? On the other hand, you have apparently much more planning time, because it's a totally different kind of solver that needs some resources. Maybe you're into Cartesian path planning. Many of us are, I guess. And you used the compute Cartesian path module of MoveIt before. Maybe you're happy, and that's fine. Maybe you're not. And if you're not, you should have a look around, and you might find dcar, right, which gives you under-constrained Cartesian trajectories. And you can just use those, for example, right? So in this specific setting, we just specified, please tip over the bottle above the glass. So there's one, we don't care about the yaw axles of the bottle, and that basically works out of the box. So just use it. We're currently thinking about integrating that with MoveIt. There's an open issue on that, but we'll see how it goes. Then, the never-ending story. Yeah, upgrade grasping. It's the most frequent request for sure with MoveIt, to say, yeah, I want to grasp stuff. Yeah, well, in general, it is no solved problem, whatever people want to tell you, right? Not in general, it's not. So if you come up with a picking scenario as an engineer, then it's quite likely that it's possible, because you are the one who came up with it, right? So in your scenario, you pretty much know how to grasp and what to grasp, and you are the one who should provide the grasps, right? MoveIt has a pipeline that supports your solution, so your own solutions there. We have a pick-and-place pipeline. It's not too intuitive to debug, I have to concede, but it works. And if you feed in grasps, then you get full collision-free trajectories that pick up objects. So two prominent modules that generate such grasps for you. On the one hand, MoveIt simple grasps. Dave is, as far as I know, currently looking for a maintainer for that. So if you use it or want to use it, please feel free to step up. This just generates simple geometric grasps for primitives. On the other hand, there's research projects like the grasp post generator module from the Helping Hands Labs and Northeastern University. And you can just plug that into the ROS system and feed it to MoveIt. So we have a Kinect camera here observing the scene. The grasp post generator just generates some valid grasp based on the geometry of this whole stack, right? There's no modeling involved at all, but depends on what you do. That can work quite well, and it will pick up stuff one after the other. It might pick more than one, right? There's no model in there, but it always depends on your application. And of course, there are lots of visualization tools. You should use them, seriously. MoveIt Visual Tools is really, really good for debugging your internal problems there. Relo is a very nice tool for analyzing the workspace restrictions of your setup. Yeah. Going on to the next part, my group at TAMS, we propose and publish hereby a new kinematic space plugin for MoveIt called BioIK. It's basically it is the master thesis of Philip Ruppel at TAMS, so he did a very great job implementing that. It's based on genetic algorithms, particle swarm optimization, some memetics in there too. And it's a very, very efficiently parallelized implementation. It improves on TrackRK in success rate and performance, even though it's particle-based. And given that TrackRK already has a success rate of 99.9% in many cases, this is really something. It allows for intuitive approximate solutions. So you actually see that the arm tries to reach 4 targets, and if you allow approximate solutions. It can handle multiple goals, including secondary objectives. So if you want to be somewhere and, for example, keep the elbow up or down, or stay with your whole torso above your center of mass, which might be something you heard in Luca's talk earlier, then you can feed it in there. And there's much better generic support for non-6D DOF arms. So because we're using dexterous arms, dexterous manipulation in our lab, and because we have shadow hands, and because Shadow will also present later, we obviously have a shadow hand in the demo. So here we have 5 end effectors sharing one chain from the base of the whole arm. There's a KUKA arm attached in this scenario. And as you can see, as you move around, drag and drop around the end effectors for the individual subchains, you see that even the whole arm changes its orientation to account for the configuration, right? So this is really great plugin. We have various goal types. I just scratched that earlier. Position orientation, of course, look at joint variable constraints, center joint constraints, minimum displacement, which is quite nice to say, I want to stay close to my pose, for example, for compute Cartesian path applications. Keep contact using FCL implementation, balance center of mass, and of course, it's a particle-based implementation, so you can feed in any function there you like. The code is available on GitHub. There will be an official release soon. We thought it might be a good idea to have you guys try it first and get some feedback. So there will be a release soon. Next thing, yay, we already announced it twice. There will be more World MoveIt Day 2017 taking place in October 18th, next month. We already have several event locations confirmed. For some of them, you can just go there and take part, and there will probably be free food. But even if you're not going to go to one of the locations, you're very happy to participate online from home or wherever you are. Right? The idea is to improve many small things in the project. So join us, help us out, please. Okay, to summarize, for upgrading MoveIt, upgrade your experience. Don't consider MoveIt to be the framework you used 2 years ago. It's not that the whole framework changed, but a lot of minor things changed. A lot of annoying bugs went away. Maybe there are many new ones. But you can file issues, and we will actually respond to that. Upgrade your possibilities. Don't expect that MoveIt does everything for you, right? It's not the holy grail. It's out there, and it works well if you know how to configure it, but there are also many third-party editions that make it work much better. And then upgrade MoveIt, so the actual upstream project. If you have some time to spare, for example, for writing documentation, for writing tests, for implementing small API functions, for example, for the Python API, and if you have some useful modules, please contribute to the upstream project, right? So MoveIt is community-driven by now. If you participate, then we can move forward. Thank you.
Thank you. We have time for probably just one question, and while that's happening, Adam and Karsten, come on up. just a question or two. Yeah, house left.
Thank you for nice presentation. So my question is regarding your sentence about changes in the code were painful. So you try not to change it in the MoveIt. So the question, how can you estimate current state? Do you have some mechanism which allow you to at least check that you haven't break something? Have you developed something, some unit tests, integration tests, or are you still under like uncertain conditions? Thank you.
So one of the points where MoveIt lacks most at the moment is integration tests. So I want to make that a big point on the World MoveIt Day. But checking for API changes can be done automatically. There's API checker out there. It works well. So that's what we do.
Thank you.
All right, time to move on. Thank you very much.